couple of sentences about myself. I've been launching startups into the cloud, so to speak, for the last 12 years. And here I'm about to share my experience with monitoring distributed applications in the cloud. So originally, I plan to talk about mainly Prometheus itself and its data model and how to build efficient dashboards out of Prometheus data. But while preparing the contents, I realized it should be nice to actually mention the background of why everyone is raving about metrics monitoring and Prometheus in particular. So this talk is focused on why do we need metrics and why it can be useful, and starts talking about Prometheus. And in 2 weeks' time, we actually have another talk, part 2 of this mini series, where we'll go deeply into the Prometheus itself. So having said that, let's get started. Right, so you start your new project on the cloud, and be it GCP or AWS, those I've worked with, and you already get quite a lot out of the box, right? So if I'll go for the short demo, this is my VM instance on GCP, and it has nice CPU graph, network bytes, etc. So it's quite lots of visibility, but one thing is obviously missing is memory, right? And that's quite an important metric. So, and it's been like that since I used the cloud for the first time in 2008. So still, we don't have out-of-the-box visibility into the memory, right? Now, with containers, it gets a little better, at least on GKE. So if you configure your YAMLs right, you can actually get memory stats out of the box. And again, here is demo. So I have my Kubernetes deployment running here, and it's out of the box Kubernetes engine dashboard in GCP. And here I have my memory. Nice. But what I really want is the application metrics, right? I want to know what my application is actually doing, whether it's clean apples or processing parrots. I want to know what's happening inside, because application can have a perfect CPU, memory, disk, and network metrics, and actually sit there doing nothing. And because it hit out of memory error if you're in Java and enter the zombie state, right? So we do want to see the heartbeats of the application. So app metrics are important, and we do want them. So why metrics, right? So we have logs. Whatever software we developed wrote some stuff on the standard output since its inception, which later we started to call logs, and they did well for quite a long time. So the thing is, log is hard to see the big picture, particularly with microservices. We now have logs from 20 processes running on 20 different VMs, and you need somehow to correlate like what's going on. So it's hard to see trends, right? They're very good for debugging, but in day-to-day life, you want to see trends, and you want to have alerts on those trends when something is not happening as it should. So the thing is that there are solutions that try to in a way to retrofit metrics like monitoring on the existing applications. Let's say legacy applications that you don't have access to their code and you can't change. So you can actually do several things. For example, if you are on GCP, you can create logs from metrics. And here is another quick demo. I have logs of my container. I can click on action and create metric from that, and then I configure a particular log message that I want to count wherever it appears, and I'll have a metric, right? So kind of nice out of the box. So the problem is that it's a lot of additional operations to do after you develop your code. So develop your code, you launch it, you look at the log messages, and then you configure metrics, and it is disjoint. So whenever whoever writes logs in your application, that person is not necessarily aware that there is some other system watching those logs and generating metrics from them. So it's easily to break those. In particular, if you're monitoring for errors, someone changes the error message, and then your log metric is not capturing it anymore. So you live in fallacy that everything is right and ticking, while in fact you have lots of errors in your log that you not monitor. So to combat that, additional SaaS solutions developed. One that I know of is called CoreLogic. So what they try to do on many other things, they try to parse your logs and recognize the templates. So like in my example, they see there is certain log that appear regularly, and most of it is constant, and there is just one variable that changes, so they automatically generate metrics for you. So again, it's a nice approach, but in my opinion, it's mostly useful if you have an existing application that you can change and you do need to monitor it somehow. Okay, so I mentioned metrics all the time. What is metrics actually, right? So the metric, basically, it's just a key value series attached to a certain timeline. So basically, it's consists of just samples, with each sample being made from timestamp, metric name, and some usually numeric value that represents whatever we're trying to measure. And all of the above that we saw in Google examples I showed, they actually metrics behind the scenes that Google just collect them by itself. So let's look at the example. Let's say we have a web application that serves some web requests, and it's split into processes, and we basically log our metrics in a certain way for the future collection. So we have process A, we have metrics with a timestamp counting total HTTP requests at every certain time, right? So this is something called the counter, which grows over the time. We will talk about that in much more detail in a second part. Yeah, right. So now what we can do is we can aggregate all of the data in some kind of central database. Then we can bucket it by minute, calculate difference between every minute, and we can know our request per minute that our application serve. So we can add more processes, remove processes. The system will just keep working and allow us to see the data. Now, this was kind of the first iteration of metrics, I assume about 10, 15 years ago. And then smart people came and said, yeah, let's add dimensions, right? So here is our metric. We are measuring HTTP requests, but what if we want some more details? For example, we want to see requests by the response code. So we want to filter like 200 requests and 404 requests, etc. And we don't want to introduce additional metrics for that because it will make it hard to aggregate. For example, if you split it in different metrics by status codes, then how do you calculate the total amount of requests? So they said, let's kind of make a logical grouping and say, we keep the same metric, but add dimensions. So like in Prometheus format, this is how it's written. So we basically now have a dimension called code. And instead of having one number, we have two numbers across a dimension, right? So we have 1,227 responses of 200 and 12 errors of 404. And similarly for process B. And the next logical step is say, well, what's actually process B? In fact, it's another label by itself. So whenever all that stuff ends in my database, it just has labels, and labels can be my application grade labels, say, which I introduced in my application, and collector level labels, which say where this metric was collected from. And this is how metrics flow, again, in Prometheus world into the storage. Yes, and of course I can introduce more dimensions. For example, I can split it by path, but again, following this particular example, you need to be cautious. If your path is something generic, for example, based on user ID, and you have billion of users, that will generate like obscene amount of metrics, and this is part of the planning and designing your monitoring, whether you want that amount of information to be stored or not. And finally, when we have our metrics in database, we can graph them. And here is one example in Grafana that shows requests per second for each of the passes, our application source. Right, so I started to talk about metrics explosion. So let's try to figure out how many metrics, how many of those series do we need? And it became a big number quite quick. So in my experience, if you have an application that's built for numerous microservices, on average, a microservice will have about 1,000 metrics. So 1,000 of those time series. And on your modest size application, I refer to a set of microservices here as an application. So your modest size application of 20 microservices will create 80,000 samples per minute. So 80,000 tuples of timestamp, metric name, and value every minute, which amounts to 3.5 billion samples per month. The thing is, it's just for your application, right? So it's just for your application. It's not for your kernel. It's not for your Kubernetes. It's not for your OS, your IO, your disk. And if you run on Kubernetes, which also speaks the same Prometheus metrics language, which became the default industry standard now. So each Kubernetes node will on average generate easily between 10 to 20,000 metrics per node. So for your 15 node cluster that runs your 20 microservices application, let's say it's 1.2 million samples per minute, right? And that's assuming I collect data every 15 seconds to give us kind of a good real-time resolution, right? And that alone amounts to over 50 billion samples a month. Now, we are talking here about 15 nodes cluster with 20 microservices. It's not a big setup, but that's already lots of data that's available to us, and we'd like to store the data and analyze that. So let's see what are our options, right? Lots of data. So how do we digest it? So in my world, no matter what you do, I prefer to stay in a single pane of glass. I don't want to have my operating system metrics in stack driver and my application level metrics in Grafana, let's say. I want to have it all in one place. And having that as a requirement, let's see what we have. So we can stick with the vendor. In fact, if you go with AWS or GCP, you already have CloudWatch or Stack Driver. You get metric collection that's already in place. You have lots of metrics about your operating system. So you only need to throw in your application metrics. And in fact, both CloudWatch and Stack Driver support that for a long time. And as I said, system metrics are already there, so it should be a kind of easy task. Just ship your application metrics to complement the picture you already have there, and you should be good. The only thing, it will be costly, and I mean costly. So the GCP charges $84 a month per 1,000 metrics, right? So now we'll see the calculations later, but doesn't sound cheap, right? So then we get to AWS, where it starts with $300 for 1,000 metrics per month. And if you use it a lot, then the price goes down eventually. Now, if we do a quick calculation for our sample application with 20 microservices and 20 microservices and 1,000 metrics each. Yeah, so, and by the way, logs are also not cheap, but it's peanuts compared to the metrics. So doing that calculation, we can see that we're going to ingest 20,000 metrics per month for our application alone. And it will cost you $1,700 on GCP and $4,000 on AWS, right? And it's only a tip of the iceberg, because I'm not sure how they charge you for metrics that change, because with containers come and go and metric change all the time. So again, I'm not sure how they charge you for large amount of short-lived metrics, but this is kind of the baseline of pricing that you want to pay for that. And there are other things to consider. So these are not multi-cloud solutions. So if you use CloudWatch, if you're on AWS, you use CloudWatch. If you're on Stackdriver, well, theoretically it can work with AWS stuff as well. But again, I'm not sure if it's the path you want to go with. It's limited to 1 minute resolution. So if you want a more real-time data, for example, for certain services that are important to you, want to collect data, let's say every 10 seconds, this is not something that's available to you, neither in AWS nor in GCP. Okay, so so we covered that, and let's continue our due diligence towards our options. And the next is we can evaluate existing SaaS solutions. So, and there's heaps of them, absolutely heaps of them. This is just a short sample. So we have Datadog, SysDig, New Relic, Splunk, and Sumo Logic. I think these are the most famous ones. I had some experience with Datadog and SysDig, though it was some time ago, and New Relic as well. We also have a hosted Grafana, which is interesting kind of hybrid solution I will talk about later. The pricing is hard to figure out because it's kind of enterprise solutions, but it will make sense why GCP and AWS charge what they charge when you get there with the pricing. Though I must say, they do offer lots of additional features. For example, they do anomaly detections of various kinds. They can help with security audits, etc., etc. And of course, they are multi-cloud. So no matter where you are, they can, if you're on one or more clouds, you can bring all your monitoring data over there and have that single pane of glass I was talking about. The thing is, because they are independent solutions, you need now to shift there not only your application metrics, but your system metrics as well, because you want to correlate application performance, for example, with CPU and network performance. And this can become expensive quickly. Now, moving on to the main part is host your own. And this is not as complex and scary as it may sound. So basically, first step we need to do is we need to instrument our application, which is something we have to do regardless what kind of collection we do, whether we use GCP, AWS native or SaaS or all your own. You need somehow introduce metrics into your application. And then we need to collect and store that stuff somewhere. And then we want to have dashboards, and we want alerts on those dashboards to understand, because we don't want to watch them every night. Now, I want to start from right to left and actually go with display and then collect and finally give a glimpse on how to instrument an application. So let's start with display and alert, right? So Grafana is de facto dashboarding software for DevOps and beyond DevOps. It's used everywhere. It's well maintained. It's ubiquitous. There are plenty of out-of-the-box dashboards available for many products out there. So and it can really build a beautiful software. Now, designing DevOps dashboard is an art of its own. It's kind of subdivision of user experience design, and I you can literally spend hours without noticing perfecting your graphs. Yeah, but it's fun for me, at least. It's a great fun. Now, the thing about Grafana, that it supports multiple data sources, and by multiple I mean dozens of them. So you can have hybrid application that process some emails from AWS in your container that runs on GCP and then pushes unpacked data into PubSub. And now you can actually monitor on that in Grafana. You can just connect it to all the 3 data sources. So you can take simple email service metrics from CloudWatch. It can take your Prometheus metrics from your container and can take PubSub metrics from Stackdriver and present it in 3 different graphs all on the same dashboard. And it's, yeah, and it's very easy to see and use. Now, so with Grafana, you can actually have that hybrid SaaS thing. So you can go to Grafana Labs and create an account there to have a hosted Grafana for yourself. And then you can connect it to CloudWatch and to Stackdriver. Now, Grafana Labs, they don't just provide Grafana itself, they also provide you a hosted Prometheus service where you can ship your metrics. And the price, though still expensive, it's much, much cheaper than the one you have on GCP and AWS. And you only need to ship your application metrics there. So again, going to this example, you ship your metrics to a hosted Grafana, and you connect directly to CloudWatch and Stackdriver, and you can kind of have that hybrid SaaS solution without actually rolling your own metrics collection, just the dashboarding. Right, so this is kind of interesting part that I suggest you look at if you're going through that monitoring due diligence process. Still, though, you'll be limited to 1-minute resolution for data you pull from CloudWatch and Stackdriver. Okay, so we're done with display, and Grafana can do alerting as well, but alerting is a long, different story, which can deserve a series of talks of its own. So let's put a check mark here and move to collect. This is a nice reference to StarCraft 2 character if you played one. So you'll get the slides, click the link and watch. So let's collect. The question is where to collect and how to collect, because we have 3 billion application metrics and 50 billion system metrics every month, and we probably want to store them for more than a month. And storage size of each sample will play a role, a big role here. So let's say a couple of existing database general purpose solutions. So in my experience, MySQL takes about 50 bytes to store a timestamp, metric, name, and value sample, including all the indexes, etc. So for 50 terabytes, it will take, sorry, for 50 billion samples, it will take over 2 terabytes. And of course, it's not distributed, etc., etc. Now we can go with Elasticsearch, and it will work. In fact, Elasticsearch comes with its own suite of metrics monitoring solutions, but it's still 20 bytes per sample, which is 1 terabyte for 50 billion samples we have. So if we convert it to dollar figures, we'll have, and 3 months retention, we'll have almost $1,400 for MySQL and $500 for Elasticsearch. And the thing is, it doesn't sound too much, but that's just for storage and just for your one application. By application, I mean the set of microservices, including all the container runtime that it runs. And again, it's just for the storage. So the thing is that metrics data is unique, and we are storing that in general purpose databases that can do many other things that we don't need necessarily. So for example, our metrics are immutable. They represent events that happened in the past, and that data doesn't change. We are not rewriting metrics. So once we wrote the timestamp, it stays there. We are not updating old metrics ever, or at least we can assume that. And the thing is that metrics also don't change often. So there's lots and lots of metrics that, for example, those who monitor errors and hopes that errors are not too common, they look like 0, 0, 0, 0, 0 for a week, and then you have 1, 2, 3, and then you fix the bug that goes back to 0 and stays there for another 3 weeks, right? And these with traditional database, cost of writing, zero value samples and non-zero value samples is the same, which is a waste in our case. So many smart people realized that there is the opportunity to create a specialized technology. And this is how the whole trend of time series databases was born some time ago. And finally, we can get to Prometheus, which this talk was about. Okay, so let's look at Prometheus at glance. So it's not the first time series database there. We had the Graphite long before, but it became a golden standard in a way that its metrics format and its query language kind of became the official standard. And now, for example, Kubernetes itself exposes metrics in Prometheus format, which actually now called Open Metrics, which evolved into Open Telemetry, being part of CNCF Foundation. And there are many other databases that store metrics. They are not necessarily Prometheus, but they do implement Prometheus query language. So Prometheus query language is very different from SQL. And again, we'll talk about that in part 2. But it became the sequel of time series databases. Now, its storage layer applied all the requirements I mentioned in the previous slide about the properties of time series. And hence it realized storage layer that takes only between 1 and 2 bytes on average per sample. So just imagine that we have a metrics name, which is quite a long name. When we have a value, which is float, which is alone is 8 byte, and we have a timestamp, which is another 8 byte. And all of that, we are somehow managed to shove into just 1-2 bytes per sample. So how do they do that? So of course they do normalization, right? They keep metrics name aside and store just metrics IDs, but the other things they do, they store deltas. So if metrics change from 5 billion 1 to 5 billion 2, they don't store the whole value, they just store the deltas, and they of course do the bitwise optimization, so it takes very little space. And if metrics doesn't change, they just write a special mark, what they call, I think, tombstones, where they say, okay, that metric, it's still here, it didn't change, so whenever you query, just go back and look for the last value that was in my database. So that was the storage. Now the ingestion. Okay, storage-wise, we have very efficient engine, but we still, for application, need to process about 1 million samples per minute. So the thing is, you don't need the cluster for that. Actually, you can launch Prometheus on your laptop, and it can easily, and I mean easily, ingest 1 million samples. Yes, while you still can browse the internet on the other cores. So it's very linked solution. And I had, in my previous company set up a Prometheus server with retention for 4 months, which was monitoring that 20 nodes cluster with millions of data samples coming in, and including storage and compute, it cost me about like $200 a month. And that's with 15 seconds resolution that you don't get on most of your SaaS solutions, right? So there are benefits, and it's because it's so simple, just one server. It was super stable. So in fact, I don't think we have any problems with that ever. It just worked. Now, as I said, Prometheus is not just a database. It can do other things from that ingest, collect, and display pipeline. So first to do the discovery. So you have your applications, right? But someone needs to know what applications to collect data from and how to collect that. So Prometheus can discover your virtual machines because it knows how to query both GCP and AWS discovery APIs. If you run it into Kubernetes, it can poke Kubernetes API to see what pods you have and whether those pods have a metrics to collect. So after discovery, it pulls metrics from targets. So contrary to StatsD, that is kind of previous generation of metric collections, metrics are pulled and not pushed. And then it stores data and allows to query them using its famous query language, or it can ship them further to, for example, to a big Prometheus server that collects data from multiple Kubernetes clusters, or an alternative database that understands Prometheus protocol and stores metrics in long term. So let's look at it from a 10-feet view. So we have a Kubernetes cluster, which has some pods and of course, Kubernetes metrics itself. We can launch Kubernetes inside. Because it runs inside the Kubernetes, it can see what's there, what pods do we have, and can dynamically discover new pods when they appear. Then it can pull the metrics from the pods. In parallel, we can have another application that runs on traditional VMs. So we can deploy another small Prometheus server to again watch our VMs as they come and go and collect metrics from them. And now we can ship all the data to a central Prometheus. So it can be another Prometheus-like database, for example, Thanos or Victoria metrics. And we can query that central database with Grafana to build our dashboards, build our alerts, etc., etc. So at this point, we've done with collect and store, and let's move to the instrumentation. Now, this is a quick Python example. So basically, you do need to think what metrics in your application are important. And again, it can be like a whole topic for itself. What are the metrics you want to monitor? What the errors you want to monitor? Whether you want to use histograms or just summaries, etc., etc. But it's a quick example. So I'm using Python Flask here to define a hello world. I create metrics of the type summary. And again, we'll talk about that in the part 2. And then I decorate my request handler to measure time it takes to handle the request, right? And then I have my main function that does two things. It starts the metric server on a dedicated port, and it starts the application on its port of its own. So one thing you don't want to do is you don't want your myglorioussite.com/metrics be publicly available. So Google will actually fetch your metrics from there and make them publicly available in the search results. It can contain a lot of delicate data about what happens in your application's tummy. So yes, pay attention to run it on a dedicated server. Now, if I run my application and I call my hello world a couple of times with curl, I can fetch my metrics, and metrics is just a text data. So it's a text protocol, and here's the metrics. Here's the application metric that I introduced. You can see it has help, it has type, meaning it has name and summary, and it says you fetched your request was handled 2 times, and in total it took very little number of time. As a freebies, we have a lot of other stuff. I'm not sure if you can see there because of the font, but basically we have Python internal metrics saying the amount of garbage collections run, about the memory, open file descriptors, etc. So this is app application that, the minimal application that this already has like 1, 2, 3, 4, 5, 6, 7, 8, 9, about 10-ish kind of metrics before I started anything. So just to give you a sense where those 1,000 metrics per microservice comes from. Okay, so to recap, if you roll your own, you need to implement, regardless of what you do, you need to instrument your application. Then if you're on your own, roll your own, you need to implement collection, display, and alert. So the way you do that, you deploy Prometheus close to your distributed application so it can discover the components of that application dynamically, and it has lots of modules to support various environments. It supports both GCP, AWS, and Azure. It supports Kubernetes and other container systems that are not in much use anymore, I assume. It's the support, the amount of supported environment is quite big. And then you collect your metrics locally, and then you need to ship them internally. So this error can go actually both ways. So they can either push data to what they call remote storage, or the central Prometheus can collect this data from this kind of agent Prometheus is, and then you have all your data here. It will have a longer retention. You can run certain policies on that, for example, to create roll-ups from low resolution data to high resolution data for a longer term storage. And then you have your eyes into that CO data and alerting system in place. So more to come in part 2. There we'll talk about Prometheus query language in details, and to understand that language, we need to understand how Prometheus stores the data. And I'll go into details about all the quirks of why sometimes your graph do not make any sense, or only make sense every whole minute and not in between. And it's a bit of a dark magic, but eventually it is what it is with the monitoring.